Hi, this is Tom, and this is our last video in the central limit theorem section. So here's what I want to show you. So an NBA team must have 12 players. They can have more, but they must have at least 12. So we'll use 12. At least 12 players. The average height of an NBA player is 6 feet 6 inches tall, or that would be 72 plus 6 more, or 78 inches. So we're going to do two things. The very first one is, one is find the percentage of American males (78 inches or taller). Okay, well, this is something that we've been working with this, and we're using the same data that we've been using before. And so here's our curve. We said the average height of an American male is 70. And then we have 1, 2, and here's 3 standard deviations above, and 1, 2, 3 below, so that's 74, 78, 82. So what this means is, what percentage of American males fall into this little orange tail right here? Well, this is something that we can easily do on our calculators. And so let's do this on our calculator. We're going to use the normal CDF function. Normal CDF. And remember, you access that by pressing second. And then press the button that says stat. And you'll see it as the second option down for you. So go ahead and go there, but you're going to press second and then stat. Oh, I'm sorry, press second vars. I made a mistake, so let's fix that. You press second and then the button that says vars, and that'll take you to the distributions. Okay, so now that we're there, you're going to choose normal CDF, and then it's going to ask you for your lower bound. So your lower bound is always the left. This is the lower bound. And so in this case, for your lower bound, you're going to enter 78, then enter. Then it's going to have your upper bound. Well, upper bound here, this is infinity. This is infinity. It goes out as far as you need it to go. Well, on your calculator, what you're going to do is you go press the second, and you'll see an E, which is right above the comma. You'll see the E. And then you're going to type in 99. And that's how you tell your calculator. It'll display on your screen as E99. And that's how you tell your calculator infinity. So E99. Then our mean, our mu is 70. And our sigma is 4. So go ahead and put those numbers in there. And if you run the calculation, what you're going to find, so this is 78, E99, 78, sorry, 70 and 4. And when you press go, you get 0.0228. So not very much. About 2% of the population of the males are 6 feet 6 or taller. Now, here's where it gets interesting. This is part 2. Part 2 says, what percentage of American males of groups of 12 have an average height of 78 inches. Well, let's try the problem again. So here's our picture. Well, now what happens then is, well, let's draw this up here. Let's look at this. Notice that if you were to just take the standard deviation of 4 and you were to divide that by the square root. So let's not even use this picture for a bit. And notice this. We'll do this in a different color to keep track. So if I take the standard deviation now for my sample means, well, that means I take the original 4 and I divide it by the square root of 12. So if you take a moment and take 4 and you divide it by the square root of 12, you're going to find that that's about 1.1, or even figure 1. So in other words, in 3 standard deviations, 1, 2, 3, your normal curve has got to fit all of it inside of there. So it's going to go way, way, way up high. And then it's going to come racing back down. And notice that. But wait a minute. We're talking about an average that's all the way out here. Well, looking at the picture, that's just this little sliver of area. Doesn't look like very much. Well, you can't even do this problem using your tables because the number is so small. So let's do this in your calculators. So to find the percentage of the population where the average x bar is greater than 78, we're going to use normal CDF. And you should try this. And again, nothing changes. Our lower bound is 78. Our upper bound is, again, the infinity, which is E99 on the calculator. The mean is still 70, but now the standard deviation becomes 4, and you can type it just like this into your calculator. 4 divided by the square root of 12. And so I'm going to take a moment here, and I'm going to do that. And let's see what I come up with. Divided by whoa. So I get a number that looks like this, 2.14, and then there's some more numbers, and then it says e to the minus 12. Well, what that means is there's so many zeros before the 214, your calculator can't even show them. And so to write 214e to the minus 12, you have to move the decimal 12 places back to the left. So that means there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros, and then the 2, 1, 4. Or if you wanted to write it as a percentage, that would be 0 point. Then you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, and then the 2, 1, 4. But wait a minute. Either way you do this, this number is so small that it's essentially 0, meaning something like the NBA shouldn't even exist. Anyway, that's the power of the central limit theorem. It shows us now that when you're talking, if you identify, we naturally identify things we naturally identify groups by an average, like the average height of NBA players, or maybe the average weight of NFL players, or something along those lines. And now we can measure people based on groups and see, well, what is the likelihood, or what is the percentage of groups that share that characteristic? And that's the extension of the central limit theorem. Hope that helps. Thanks for watching.